Tyler from Profiler Tech here in New Zealand. Today I'm going to show you how to use our MMS7000 Profiler, the Profiler column I've got here on the lathe. Before we get started, let's take a look at what you get in your MMS7000 kit. First of all is the MMS7000 handheld itself. This is a rugged industrial handheld with a full touchscreen and colour display and a connector on the top to allow you to connect it to the sensor. This is the Profiler sensor itself. It has a rolling wheel which rolls along the surface of the commutator and a spring-loaded yoke that measures the displacement. This sensor is capable of measuring surface deformation down to just 1 micron. To mount that kit on a machine, you use this spacer kit. Normally you'll fit the sensor in the brush box and use these spacers to pack it out before tightening the locking nut. Finally, we have an AC charger, USB communications cable, a USB stick containing our EvoSoft desktop analysis software that you'll use on your PC to import the recordings from the handheld and analyze them and produce reports. When you first power on your MMS7000 handheld, this is the main screen you will see, and we'll get to how to use all the functions in a moment. But before we start, we need to connect our sensor. The sensor just connects straight to the top of the handheld and is held in place by the locking ring. Before we take our recording, we need to mount the sensor against the surface of the comm. The sensor yoke is spring-loaded, so we want to press it against the comm so that the yoke is compressed to about the middle of its stroke. And that's shown on the position sensor screen on the MMS7000. So what you want to do is get the sensor so that it's about the middle. It doesn't need to be exactly zero, but about the middle. Then we tighten up the locking knob to lock it in place. Now we're ready to take our recording. When measuring a commutator, you normally want to record one full revolution of the comm. So it's a good idea to make sure you mark a bar as the start and end position. Also on commutators, always be sure to make sure that the sensor is positioned on the face of a bar before you start recording. That's important for the MMS7000 to be able to correctly detect and count bars as you take the recording. To take our recording, first of all we mount the sensor against the commutator. Normally you'd mount that in the brush box, but here on the lathe we're just using the block. Then on the MMS7000 we tap the measure button and we're presented with this screen. In this particular case, we're not measuring a slip ring, we're measuring a commutator, so we're choosing a bar or segment type recording. You can also set the recording to automatically stop after it's measured so many bars, but in this case, we'll stop it manually. When we're ready to go, we tap the proceed button. This brings us to the position sensor screen, and this is used so that you can adjust the position of the sensor in the holding block so that we start in the middle of the sensor stroke. It doesn't have to be exactly in the middle, but the closer the better. When you're ready to start recording, we tap the next button. We're now on the measuring screen, and now we can start rotating the comm. Once you're ready to start the recording, just tap the start recording button. Then rotate the comm, keeping an eye out for that marker you created before to make sure you do one revolution. As you record, you can see the MMS7000 is updating and showing me how far the sensor has traveled, its current displacement, and how many bars it's currently counted. Let's go all the way around. So here we can see this comm has 128 bars. When you finish recording, you'll see this summary screen. It tells us we recorded 128 bars, and the total indicated run out, which is the difference between the highest and the lowest point on this comm, is just 6 microns, which happens to be between the last and the first bars we measured. The maximum bar to bar, which is the 2 bars with the largest height difference, is bars 1 and 2 at just 2 micron, but the mean bar to bar for all bars on this comm is less than 1 micron. We can tap this button and see some stats for each group of bars, and here we're using a bar group size of 10 bars. So we're looking at every group of 10 bars around this comm. The group with the largest mean bar to bar is the first 10 bars. The average across all groups of 10 is less than 1. The largest run out between any group of 10 bars in this case is 3 microns between the first 10 bars, but the average across all groups is just 2. We can then tap this button and look at a plot of the comm. Here we can see the plot looks pretty bad, but the scale is only 1 micron down the side here, and so it's actually in pretty good shape. Finally, we can see a radial plot. This takes a moment for the handheld to draw. Well, this will show you a view of what the comm would look like if viewed end on. Again, it looks quite out of round, but the scale is very, very small, and so this comm is in great shape. That's it. We've just taken a recording with our MMS7000 Profiler. Next, we'll show you how to offload the data off the handheld and into our desktop software so you can look at it in more detail and produce reports. To find out more about the MMS7000 Profiler, come visit us at www.profilertech.com. Thanks for watching.